Sorry. My name is Johan Beest. I'm from the RIPE NCC. I'm a software engineer on the RIPE Atlas platform, and I'm going to be explaining to you today how you can discover missed peering opportunities using RIPE Atlas and specifically a tool called the Country IXP Jedi. First a question, how many people here have heard about RIPE Atlas? That's pretty much everybody, so that's good. How many people here host a probe? That's also pretty good. Okay, then I'm not going to be wasting too much time on the introduction. So this is the coverage of the RIPE Atlas network. The green dots are the connected probes, and the yellow dots are currently the disconnected ones. As you can see, we have pretty good coverage throughout the world, at least in all the occupied places. Anywhere people live, we tend to have lots of probes. So this is an actual probe. It is essentially a TP-Link wireless router. It's connected only on wired. We do nowadays have wireless measurements, and will be done. So what can these probes do? So they perform built-in measurements toward the root name servers, meaning that every probe does ping and traceroute measurements towards the root name servers. So the A, B, C, K root, etc. You can also participate in user-defined measurements, meaning you can, if you're a member of RIPE Atlas, you can create your own measurements. What kind of measurements are we talking about here? Well, you can do ping, traceroute, DNS, SSL, NTP, HTTP measurements. The measurements are done from the probe's perspective, and that is what makes RIPE Atlas unique. Instead of going from your computer to any location on the internet, you can actually tell our network to measure a particular location. So for instance, you could say, let's say that a website in Oman is not reachable from America. You can create a ping measurement or traceroute measurement from American probes to your website in Oman and see why it's not reaching your website. That's what makes Atlas unique. Sorry. Doing these measurements, you can use either the RIPE Atlas resolver, which in this case is the Google one, or if you want to be more accurate, you can use the probes resolver, which means that you get the resolver that your probe's network gets, usually using DHCP. We also have RIPE Atlas anchors. An anchor is essentially a probe, except that it's in the form of a 1U server. It is intended for bigger networks and people that want to do more elaborate and extensive measurements. So what do the anchors do? Well, they essentially do anything a probe can do, but they have more capacity. They also participate in anchoring measurements. Anchoring measurements are a mesh measurement, measuring every anchor to every other anchor. They do that using ping, traceroute, and HTTP measurements. The difference between an anchor and a probe is that you can have an anchor be a target for a measurement. Normally, probes cannot be targeted. You can only perform a measurement from a probe to a target, but anchors can be also the destination of a measurement. This year we have a new initiative. We have sponsored anchors. 15 anchors will be sponsored in 2017. We have already, I think, 5 confirmed applications and many more are in the pipeline. We have some criteria for that. If you want to sponsor, get a sponsored anchor, we would like to have them located in areas with little or no coverage. We prefer not-for-profit organizations. It's hard to explain that, you know, a commercial company does not have 800 euros to put an anchor in their network. And we would prefer them located within the RIPE NCC service area. That is not really a hard criterion. If somebody has an interesting location outside of the service area, they can still apply. Applications are done using this link. You can find it in my slides. The only thing you need to do is leave a comment that you would like a sponsored anchor. So that was the introduction. I hope that it's clear what RIPE Atlas does. So now we're going to look at actually discovering the peering opportunities. We're using a tool called Country IXP Jedi, which is a tool that my colleague wrote. And it's essentially using RIPE Atlas to perform measurements to find out peering. So how does it look like? A good example is this one. We're using Sweden because Sweden has a very well-established network. What you see here are the connections between the different ASs. So it's essentially, this is a matrix. So you have all the ASs on the top and all the ASs on the left. And that's the traffic that goes through there that we see using measurements that we create using RIPE Atlas. So what we do is we take all the probes within Sweden in this particular case, and we essentially create a mesh network where all the probes in Sweden measure all the other probes in Sweden. And then we look at what the traffic does. So what you would like to see here is a nice green matrix. If it's green, it means that all the traffic goes through an IXP and stays within the country. If it is orange, yellow-orange, that means that it does go, let's see, what was it again? It does not go through an IXP. I always forget what the colors are. And it does not go out of, it doesn't go through an IXP, but it does stay within the country. Blue doesn't happen a lot, and red means it doesn't go through an IXP and it leaves the country. So that's your worst case scenario. Sweden already looks pretty good, but it's a Scandinavian country. So if we add to that Sweden, we also add Oslo and Copenhagen, we see that it's almost all green. Everything, pretty much everything stays within the region. If you compare that, unfortunately, to the Middle East, this is what it looks like. So this is the full Middle East JEDI. This includes Turkey and Iran. As you can see, there are a lot of ASs, and that makes my talk a little bit difficult. So for the remainder of the talk, we're going to focus only on the 12 Arab countries. So we're excluding Iran and we're excluding Turkey. So we're getting a little bit easier to read matrix. But as you see, it looks pretty much the same. There's still a lot of red in there. Now, one of the things is that my colleague Hisham, he gave this presentation or a similar one roughly 4 months ago. And 4 months ago, this graph was a lot more red. So a lot of people have actually taken his talk to heart and made improvements in their peering. A lot of red has actually disappeared. So that is very good news. Also, I'd like to be very clear. I'm going to show you some examples of missed peering opportunities. This is not meant to be shaming of those networks and saying, hey, look at you, you're doing a bad job. This is simply to point out to those networks, you have an opportunity to improve, and we present to you a tool that you can use to make those improvements. One of the things that you can do if you look at the Middle East JEDI is if you hover over one of the squares, you can click on it and then you can see the full traceroute result. And that's what we're going to look at in the remainder of the talk. Another thing that you can do with the country IXP JEDI is show the trace routes on a map. In this particular case, this is powered by OpenIPMap. And I only showed the IPv6 trace route here, and the reason for that is that there are not that many probes using IPv6. So this looks a little bit nicer on a map. IPv4 is a little bit too much information. But here you can see that many trace routes actually go to Europe, and if you follow the line on the left, that line goes to the States, mostly to New York or California. The AS graph, so these are all the ASs and how they are connected to each other. This is all available on the tool. So now we're going to go to some examples. So Omantel to IDM, so from an Oman network to a Lebanese network. And you can see there that it transfers through Amsterdam. And of course, that's really not what you would want. I don't know what CAT C-bone is, where those go. We don't have information, but I know Ojiro is already Lebanon again, so that is good. If you look at it the other way around, so we're going from IDM to Omantel, you see that we're going through Marseille. We're not going for Amsterdam. The paths are not symmetrical in this particular case, and that is something that you will see a lot, of course. Most of the time, the return path is not the same. Another example is going from STC to Omantel. Again, we're going through Marseille from source to destination, and if we're taking it the other way around, from Omantel to STC, we're seeing we're going to Amsterdam again. Now, Hisham told me that Omantel has a hub in Amsterdam, so that makes sense that you always see Amsterdam with them. Yet another example, we're going from Batelco to IDM. And again, we're going through Marseille, and we're also going to London. And the return path, we're going through Marseille again. Now, because I always said paths are not always symmetrical, so sometimes what you see, if you go using the tool, is that if you go from STC to Ooredoo, and then AS42298, we see that on the return path we go through London. But if we're going from Ooredoo to STC, we're actually staying within the country. So that path, the return path, actually stays within the country. So this is how you can use that tool to create these results. So the tool itself, the country IXP JEDI, is not an integral part of Atlas. It is a separate tool. You can download it on GitHub. It's open source. You can install it on your own computer, and then you can run these kind of measurements. So let's say that you want to do something only for your own country, then it is simple to set up. You can create your own. If anybody needs any help with that, then they can contact me. My email is at the end of this slide deck, and I'd be happy to help anybody set up measurements if they want to know how to use this tool properly. There are a few things that are changed in RIPE Atlas. We, of course, improve the system almost every week. And one of the new tools that was recently introduced is called TraceMon, which is another visualization for trace routes. This is what it looks like. As you can see, it goes from the sources to the destination, and it tries to visualize how those paths actually go. You can hover over all the nodes. You can get extra information on them and see which AS they belong to, who is the owner of that AS. You get PeeringDB information. We integrate with PeeringDB for this particular tool. It has routing information, BGPlay links, the Who's database, the RIPE database. All of that stuff is integrated in this tool. It's really nice. It is brand new. It was only deployed literally less than a week ago. And you can see it on any trace route. So any user-defined trace route that you make yourself, there's a tab for TraceMon, and you can check out this tool. For instance, this is some of the resource info that is available using the tool. TraceMon is also the back end for the new upcoming OpenIP map. I showed you OpenIP map earlier. And the new version that we're going to have is an updated one. The current one is essentially a prototype. The new version will use TraceMon for all the back-end logic on how trace routes work. The new OpenIP map, the new beta version, will go live during the RIPE meeting, so only in a few weeks. That was it for me. Are there any questions? No questions.
So while everyone's trying to find out, while they're getting over the shock of all the red, I should have pointed out that when we said we want you to get excited after lunch, I meant your blood get excited. You don't want to see red on the screen. Johan, I have some questions. Thank you, that was very interesting. To me it seems obvious, right? To me it seems obvious that if you want to start having more green, it seems to me that we're going to need more domestic internet exchange points. By that I mean exchange points inside each country. And then we're going to need more exchange points that are going to allow more interconnections between different countries.
Yes.
I think STC and Oman next to each other, so it seems rational to me that trace route should be, well, faster than having to go through France IX, for example. Have you guys done any analysis? Now this is great from a technical perspective. Have you done any analysis of cost of all of this? So what it would cost in terms of, say, the average price of, and I hate using the term, but say an STM1, for example?
No, we don't. I would assume that it would be cheaper, but honestly, I don't know. We don't go into that. One thing you can see, though, on this particular AS graph is that only one of the exchanges is visible. So only the Dubai Internet Exchange, we have traffic going through there. None of the other exchanges actually connect to the networks that our probes are connected in, at least not for the ones that we used for this particular measurement. So yeah, we definitely need a lot more internet exchange points, that's for sure.
Okay, I have more questions, but I see the microphones are filling up. Name and affiliation, please.
Yeah, hi, Johan. Elvis Valavi, Forest Pro. Just a quick question. Any idea how many of these local internet exchanges are in the region and connect the west coast of Europe and back in order to connect two countries that are neighbors in this region?
Yes, I totally agree. I think there are something like 5 or 6, maybe Hisham knows the exact number of internet exchanges here, not that many. You can use PeeringDB to find out who they peer with. If they have their information updated, it will be there. You could even use the Tracemon visualization because that also includes the PeeringDB information. So if you have a trace route that goes through a particular IXP, you can look at the Tracemon visualization, you can see the IXP, click on it, and you can see their peering information. Good.
Thanks, Johan.
Yep, Hisham Ibrahim. Thank you for the talk. Right, NCC. Thank you for the talk, Johan. I just wanted to touch on some of the stuff that you mentioned and also Elvis's question. Unfortunately, while we do have several exchange points in this part of the world, I think with the exception of UAEIX, there aren't other cables from other countries or other providers from other countries peering at those exchanges, and I think that's why you're seeing what you're seeing.
Sorry to interject, but that's why when you do the full one, including Turkey and Iran, you do see that.
Yeah.
That's why you get so many more ASs as well.
Yes, yep. and I think that's also something from policy or from other to see if there are certain things. I mean, I know for a fact that there's certain legislation sometimes that prevents something like this. I know for a fact that maybe it's people are looking at their domestic market and not thinking in a regional perspective, even though everybody is now trying to think outside of their country because a lot of the markets are kind of saturated and they want to seek new customers. We've seen working examples at all the exchanges in Europe, so there's no reason why we wouldn't have something like this. Second thing, really quickly, I wanted to point out, as you mentioned as well, that when we presented this a couple months ago, a lot of the operators took this information and actually went back and fixed stuff. I can mention Omantel and Do. At the time, they weren't. They went back and fixed this. And that's the nice thing about this tool. Now, for us to be able to do this stuff, you have to host the probes. We have a lot of probes to give out. That's the end user perspective. But also, we want anchors in the region. I think now the count is 4 or 5 in all of the Middle East. Yeah. It used to be 1 last year. So we got people excited about this. But the more people that see the use in this and deploy them on their networks, the better measurements we can actually do and help you, like Johan said, without shaming or naming anybody, yes, but helping identify where these gaps are that just might be overlooked. Yes. Thank you.
And one thing to point out, like Hisham already mentioned, is that we depend on probes for these measurements. So if we don't have a probe in a particular AS, or we have a probe that is down in that AS, we don't have accurate information in this tool either. So the more people will host probes here, the better our tool will become. So that's why I have probes with me. So anybody that says, like, this sounds interesting and I would like one, please come see me and I'll give you a probe, no problem.
So before we take the next question, I have to ask, is there value in doing some sort of time series data analysis of all of this information? You've got the situation, as Hisham's put it, about 4 months ago, and as you said, there was a lot of red. Now there's not so much red, but still lots. Is it valuable in doing this on a regular basis? Is this something that you'd like to see happen? Who wants to see that
I can-
map change over time?
I can answer that question right now. You don't even have to ask. We do this on a regular basis. This particular one is run every month. So if you go to the country IXP JEDI on GitHub, you can see, I can send you the links also, but we have a version for every month, so you can compare from month to month how the situation improves. I know that one of my colleagues is working on actual analysis of that data, so at some point we'll probably have an updated version that can actually show this is what it was last month and now, this is what it looks now.
So effectively we're looking at seeing more orange and yellow, hopefully at the next MENOG when it comes
Hopefully
out.
more green. That's what you're looking for.
Yeah, thank you. I'm Bernd from DKIX and UAEX. My job is to work with the members and their configurations at UAEX, so I have more or less the same questions on the table to go through. And what I would like to highlight that you even find passes over Europe from members which are both physically interconnected at UAEX, for example. And I think what is true for most of the large carrier networks is beside maybe the peering at UAEX, they are also peered, of course, at the major IXPs in Europe, so London, Amsterdam, Frankfurt. And what is missing is technically the differentiation where to primary route the traffic. So I think there is in some cases a misunderstanding of the concepts that BGP doesn't know anything about distance in kilometers. So if you put all the local pref and the metric on the same value, at the end your tiebreaker is the timestamp of the session itself and not the few kilometers away UAEX. So it would be good to have a look at this topic too, to ensure that the pass is really done next to you and not 1,000 kilometers away, just because of the missing implementation of the right metric settings.
Yes, absolutely true.
Thanks, Bernd. And that's a good point. And it ties back to what Paul said earlier on this morning when he spoke about the RIPE NCC and the need for more capacity building. So that to me